So our last video for chapter 4 is just a couple more application problems dealing with the different types of trig functions that we've gone over and different things. And yeah, sorry, it keeps wanting to auto correct me, so it doesn't like my, yeah, I can't even fix it. Anyway, it says application of tris functions. It's application of trig functions. It wants to auto correct my handwriting all the time. Hopefully it won't continue to do that in the actual video. If not, I'll have to stop it and fix that. Okay, so before we get started, there's one key component before we just do a couple application problems that I want you to be able to do. And this is the idea, I think we did talk in the last section. So there's two things. One is angle of elevation / depression. Okay, so if you have a horizon, it's just perfectly horizontal. Usually it's the ground, or it'll be kind of clear in the problem what the horizon is. The angle of elevation, of course, is the angle that goes up from the horizon. And the angle of depression is the angle that goes down from the horizon. Okay, so I think we've kind of gone over those before, but just in case, when we talk about angle of elevation, angle of depression, it's just from some horizontal line, be it the ground, or we'll see in one of the problems we do. The next thing I do want to go over that you may or may not have worked with in the past is this idea of bearings. Bearings are just simply your north, south, east, west, but as they relate around, think a rectangular coordinate system. So for example, it's important that we learn how to read some basic bearings. So the idea is you do have this coordinate system with our 4 quadrants, 1, 2, 3, and 4, right? 1, 2, 3, and 4. Okay. And we're just going to kind of place a compass over it. So we have north, south, east, and west. And what bearings do is give you 2 directions. They're either going to give you either a north-south, and they're going to give you either an east-west. And it's usually written, or it's always written, with the north-south first. So, for example, north, 20 degrees east. And we're just going to do it with degrees. What does that mean? You're starting at your kind of center, and how you want to read that is 20 degrees east of the north line. See if that makes sense. 20 degrees east of the north vertical line. Now, why is that important? You are so used to drawing angles from the initial position, which is your positive x-axis. You are now going to draw lines essentially from the y-axis, which is our north-south line. So let's take a look. I'll grab another color here. This red's fine. So that means I'm going north. So I'm going up because I'm going north. Then I want to head east. I want to head this way, but I'm only going to head that way for 20 degrees. So that angle down there is your 20-degree angle. So north 20 degrees east would be, in kind of trigonometry terms, think about it, a 70-degree angle in standard position, right? Because if that's 20 degrees and the whole thing's 90, then this is 70 degrees. So it would be a 70-degree angle the way we think of it in standard position. So you just want to be able to draw these bearings very carefully on your paper because there's an assumption of what they are. But remember, bearings always come from a north-south line. So for another one, if we want south 35 degrees east, that means we're going down and then we're shooting toward the east. Only 35 degrees. The angle is between the south and the angle itself, the terminal side of the angle. That's what 35 degrees is. And then, of course, on the opposite, try to come up with some more colors here. If we wanted to do, so think about quadrant 2. Look at quadrant 2. You're only dealing with north and west. So that one would have to read north. I don't know, let's do 75 degrees west. All right, so that means we go up north, and from the north line, I'm going all the way to 75 degrees. There it is. So there's the 75-degree angle. Okay. And we'll do one more. Let's look at, so again, what do I have left? South and west. I'll move this out of the way. So always starts, let me pick a color I haven't used yet. South, 10 degrees west. We're going south, but then we're only going to head out 10 degrees. That's your 10 degrees. You need to be careful. You're going to draw these angles, but the angle you're actually given, you may have to then interpret a complement of that angle to use in your problem. This is how you do bearings. So let's do a bearings problem first. Just going to pick one out of the book here. I'll write the summary of it out, and we'll go from there. So here we are. Whoops, don't know where that came from. A boat leaves the entrance to the harbor. And travels 150 miles. On the bearing north 53 degrees east. So how many miles north and how many miles east has the boat traveled? Okay, so you want to sketch it. You got the harbor. The boat leaves the entrance. Let me move that harbor down. And travels 150 miles on a bearing north 50 degrees east. So here's a key. Sorry, I keep coughing. When you do bearings, you need a north-south line. Draw yourself a north-south line. Okay? So we went up, go up so far north, we don't know how far, it doesn't matter, right here. And you need to come out 53 degrees east. From the harbor. And he did it for 150 miles. So this line here is 150 miles. So you need to find out how many miles north and how many miles east he actually traveled. So I'm going to move this 53. There's a couple ways you can do this. You put it down here, and I'm going to say, okay, I need miles north. That's north. And then that would be east. There you got a triangle. You got your trig functions. Now, if you happen to draw the triangle this way, it's okay. Watch. Some of you might go, hold on a second. All right, that's 53 degrees. And might draw your triangle that way. That's fine, as long as you recognize this is 90 minus 53 degrees. All right, so 90 minus 53, 90 minus 50 is 40. What's that? 37 degrees. If that's 37 and this is a right angle, that's 53 degrees. So I don't care which way you draw the triangle. In fact, it doesn't even matter which way you draw the triangle, because you still have a distance north and you still have a distance east, and those distances are going to be equal to the other triangle. Not the north and east, but the north is going to match the north and the east is going to match the east. But be careful. Make sure when you draw it, you match up the angles where they are supposed to be. Either way you do it, doesn't matter. You know the hypotenuse is 150. So just figure out what trig functions you want to use. So if I'm going to use this triangle, so I can say, hey, sine of 53 degrees equals the east distance divided by 150 miles. So in my calculator, I put in 150 times sine 53 degrees. Make sure you have the degree button on your calculator. I actually need to calculate this, so 1 second. So make sure you're in degrees. So I have 53. I hit sine. I get 0.79 times 150. I got 119.80. $119.8 miles for east. If that's wrong, feel free to email me and let me know. I like to double check. 53. Yeah. Looks pretty good. And then you can do whatever. You can do another trig function. You can use Pythagorean theorem, whatever you want to find the third side. That's entirely up to you. Part of this section is also, if you are given, or this whole chapter, if you're given two parts of a triangle, you can go ahead and find all the parts of the triangle with Pythagorean theorem and trig functions, using inverse, not inverse, everything else. Okay, so if I were to do another trig function, maybe I would then say cosine of 53. I don't like to use numbers I just calculated in case they were wrong, but that's me. Equals n over 150. So then on my calculator, I'll quickly take 53. Take the cosine of that, and then multiply. I got 0.6018. I got 90.27. So we'll keep it rounded to the tenths, 90.3. What that kind of also lets me do is do a double check of Pythagorean theorem, like 90.3 squared plus 119.8 squared comes out to that. Take the square root Oh, and I get 150. So I checked myself. Yeah, I should be able to apply Pythagorean. Since I only use trig functions, I use Pythagorean theorem just to check if my trig functions were right. And they do work. So 90.3 miles. All right, so do be able to do some of those bearing problems. You know, with angle of elevation, the biggest thing is reading the problem carefully. So I'm going to read it, but I'm going to draw it as I read it. If you really want to see the problem, it is on page 611, and I'm just grabbing number 50. Okay, here's what we got happening. We have a flagpole that's situated on top of a building. I drew that building way too big. I don't want a building that big. All right, there's my building. And then I've got this boom, 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 flagpole on top of it. Okay? All right, that's the first sentence. Flagpole situated on top of a building. The angle of elevation from a point on level ground 330 feet from the building. Ooh, oh, we'll do the ground green. Come on, green, there we go. So here's level ground. I am 330 feet from the building. The angle of elevation to the top of the flagpole. So I'll do my angle of elevation in blue for the sky. Right there we are. Boom. My angle of elevation to the top of the flagpole is 63 degrees. Okay, that's what it reads so far. The angle of elevation to the bottom of the from the same point to the bottom of the flagpole. We'll do this one in pink. To the bottom of the flagpole is only, let me get this right, 53 degrees. What's the height of the flagpole? Not the height of the building. I just want the height of the flagpole. All right. When you see something like this, I hope you recognize you've got two triangles going on. One is slightly shorter than the other. They both have a base of 330. One of them is 63 degrees and the other one is only 53 degrees. Okay? So think about it. There's the height of the building. When I do the 50-degree one, I get just the height of the building. When I do the other one, I know they're not even, but let's pretend they are, right? I get the height of the building plus the pole. So if I take those two and subtract, building plus pole minus building will give me the pole. So that's all you're going to do. So we're going to use our trig functions. Because we don't care about the hypotenuse or anything about the hypotenuse, we can just use our tan functions. So for this one, I got tan of 63 degrees equals b plus p over 330. So let me get what b plus p is. 330 times tan 63. Make sure you are in degrees. Tan 63. I got 1.96 times 330. 647. Let's round to the tenths. 0.7. This is feet, yes. Okay, do the second one. Same idea. Tan of 53, make sure I only put in 53 this time. I get 437. All right, so 647.7 feet minus 437.9 feet equals looks like you have a 209-foot flagpole. That is correct. And again, if anything was wrong, please feel free to let me know. Sorry again. So you will have a couple application problems, one with bearings. You'll have something with an angle of elevation, I'm sure. The other thing is just solving a triangle. So that means for any triangle, whatever letters they are, it doesn't matter. I'm just going to call them ABC right now. When we solve a triangle, it's very careful. We correspond the angle with the side. So the side that is across A, we call little a. The side that is across capital B, we call little b and little c. In other words, the sides are labeled with lowercase letters that correspond to the uppercase lettered angles. Always, for any triangle. Here's the nice part. No matter what you are given, you can go ahead and find every other part of this triangle. No matter what pieces you're given. So let's suppose I said that, hey, angle A was 40. Well, let's do two sides. Little a is 11.2. So that equals 11.2, and little b is 17.6. All right. So with those two pieces of information, well, you can get all the other parts of a triangle. Well, number one, you're going to use trig functions and Pythagorean theorem, called PT, Pythagorean theorem. You can use Pythagorean theorem right away, or you can use a trig function, whatever you want to do. All right. You have choices. What you'll have is a listing, and then little a, little b, little c. We already know that little a is 1.2. Little b is 17.6. I'm going to do trig functions, but you can use Pythagorean theorem to get c if you wish. That's perfectly fine. But since I have two sides, I'm going to go from angle B. And I'm going to say that, hey, tan of angle B is 17.6 over 1.2. Again, you could go the Pythagorean theorem route, try it your own way. Make sure you get the right answers. So that means tan of B equals what? 17.6 divided by 11.2 is 1.57. So tan, remember, that is a ratio. You want to keep that to about 4 decimal places because you're using it for a calculation. That means that angle B is equal to tan inverse of 1.5714. So clear that. Do second tan of 1.5714. Oops, I accidentally erased it. 1.5714. We're going to, any application problem, we're going to stick with degrees. So keep your calculator in degrees. And I get angle B. You can also put the little angle sign in front of it. Angle B equals 57.5. Now you can just round it to 1 decimal place. Degrees. Okay. Well, here's the good part. You already know C is a 90-degree angle because it's a right triangle. You can get angle A just by taking 90 minus 57.5, right? Which I believe comes to 32.5. And again, if you wanted to get C by doing Pythagorean theorem, you can certainly do that. Or you can pick another trig function. It's entirely up to you. So 11.2 squared plus 17.6 squared. I'll do Pythagorean theorem. Square root of that. I got 20.9 for side C. All right. So do be able to solve a triangle or find parts of a triangle based on what you're given. Should wrap it up for test 2, which you will have shortly. Of course, unless you're in my summer class, in which case I think you're taking test 1 shortly, not test 2. Summer's a little bit different. Anyway, you're ready for your test on the end of chapter 4.